Rules of Differentiation, Part 1. In the last section, we defined the derivative using the example of velocity. As the time interval got smaller and smaller, the average velocity got closer to instantaneous velocity. We saw that the derivative is the result of a limit. It is important to keep this idea and the definition of derivative in mind when we think in terms of what the derivative measures. It measures rate of change. However, using the definition to find the derivative is tedious and time-consuming. Starting with this section, we will learn rules to make finding the derivative an easier process. First, let's remind ourselves about the notation. If y is a function of x, so y equals f of x, then the derivative of f of x can be written as f prime of x, or it can be written dy dx, or y prime. There are other notations, but these are the most common. Let's find our first derivative rule. Notice that if you have a constant function like y equals 5, or y equals 3, or y equals 7, notice that the rate of change is 0. So dy dx, the result of the limit, is just 0. So if y is a constant function, its derivative is 0. Notice if y equals x, the rate of change is 1. Rise over run will always be 1. So the limit of rise over run is just the limit of 1, which is 1. So if y equals x, then dy dx equals 1. Another way of saying that is the derivative of x with respect to x is 1, or x prime equals 1. Another rule. The derivative of a constant times a function is equal to the constant times the derivative of the function. We call this the constant multiple rule or the coefficient rule. The derivative of the sum is the sum of the derivatives. If instead we had f minus g, then we would get a similar result. The derivative of the difference is the difference of the derivative. Let's use these rules to find the derivative of this function. A little bit of analysis tells us that the rate of change of this function is 4/3. It's a linear function with a constant slope. Its rate of change, rise over run, always equals 4/3. So we would expect the derivative to be 4/3. But I'd like us to practice our derivative rules. So the derivative of 4/3 x minus 4. First I use my difference rule. The derivative of the difference is the difference of the derivatives. Then I use my coefficient rules, or coefficient rule. I only used it once for the first term. Then the derivative of x is 1. The derivative of 4 is 0. And so I get 4/3. dy dx equals 4/3. exactly what we were expecting. We will continue this discussion in part 2.